let's go further. The first slide, just to make some impression, it's a presentation of a dynamic transport model, which we did in 2017 in Moscow, and it was presented for president and to administration of Russian Federation. So if we speak about ITS, Intelligent Transport Systems, first of all, we should define some definition of that. So if we speak about ITS, the purpose of it is to provide the required mobility to population through adaptive control, through different services, information systems, and so on. So I was once asked what is the main word in these three words, ITS. If we should define that, then I would say that it is intelligence. And what is intelligence? It is ability to adapt to new situations, to different events, and so on. So if we speak about intelligence and intelligent transport systems, we should speak about adaptive control. And what do we control? What do we manage if we speak about ITS? It's not just some separate objects. It's not like just infrastructure. It should be in a whole, unified. So we speak about the mobility, the control of mobility of transportation of passengers, goods, and so on. And to manage something, we should somehow foresee it or forecast it. And here comes a transport model as a core of the system, or a model of mobility, which helps us to forecast and calculate different scenarios based on it to understand mobility, current mobility and future mobility. So going to our software, RITM³, when we started to develop it, we put into it three main ideas or aspects. So the first one, as I already mentioned, it's a transport model, and it's multimodal transport model as the core of all the modules and tools in the platform. So it leads us to the second key idea, that it should have a unified database in terms of all the transport data should be gathered inside one database, connected with all the connections between different types of data sources. For example, we do not speak about detectors or sensors, just having only coordinates. We link them to network graph of a model, and so we do with every type of source data we have. And the third one idea is cross-platform access, like a modern access to our system. If we speak about ITS, and as Christian said before, ITS should be closely connected or even include transport planning. So it should be the one whole cycle where all the processes are connected with each other. And we made such a scheme, which you see now on the screen, where we try to show how it should be done as we see. So the first step in transport infrastructure planning is planning, which is based on model analysis, scenario calculations, data processing, and so on. And on that stage, we plan some KPIs, which we want to assess at some time. Then when we have a plan, we go to monitoring and control. And on that stage, we have an online computation of current traffic situation and forecast of it, and also analysis, which give us some facts to correlate what we planned and what is happening now. That KPIs which we had on the previous stage. And the last step is management. So we control and manage different situations through information, through direct control like traffic signal planning, and so on. And this cycle should be closed one to connect all the stages all together. And we want to implement it, and already implement it in many steps in one software. So if we speak about integration and forecasting, modeling, this slide will help me to explain that. In the center of the slide, we have three main models. The two first one models on the slide, transport model and adaptive online model, are those models which we use now in our system. And the last one, the model of mobility, is a model which is often called in scientific papers like system optimum. So if we are looking a little bit further in our future, when we have autonomous vehicles, this type of models, system optimum, will help us make the optimal routes for all the system altogether and all the vehicles. So going back to the first two models, we speak about transport model as a user optimum for strategic planning. And when we speak about adaptive online model, this is model which is used on the step of monitoring and control to forecast current situation and short-term forecast for about an hour further. And for all of that, we use different data sources, process them using model, forecast, and then we can give that information into traffic control systems, into mobile systems of users, and so on and so on. Here we see the functional models of RITM³. So we have four main models. It's transport modeling and forecasts as a core. It's vehicle monitoring and management, also WebGIS and control center. So these four models combine altogether the system, but they consist of different components inside them. Here you can see the map of RITM³ clients, which already use some part of the systems. This is mostly Russia, but also some CIS countries, as you can see. So now I will speak a little bit more about functional models, which we have. The first one is coordinated traffic management. So here you can see screenshots from the system. We implemented several integrations with Russian control manufacturers, and we are also open to integrate different open interfaces to that. So what the main idea? The main idea is first to implement web interface for traffic lights management and to link that, connect that data with traffic model, transport model, to give ability to coordinate work on the city region borders and to use data from model forecasts into traffic light optimization. If you're going further, we have model for public transportation. This model is mostly for creation of public transport network, editing of it, so routes, stops, schedule, and so on, to monitor the public transport on a route and to analyze it. Again, all these routes, stops, and so on are connected to the transport model network to use it in forecasts and on the same network graph. We have WebGIS, or as we call it in Russia, online master plan. This model is mostly used to create, edit, visualize different GIS objects which show the city plans of transport infrastructure development. So we can input data of implementation of such events or transport infrastructure development, and use time schedule to understand when which event will happen, what are the characteristics of that events, and so on. Transportation planning and road science editor helps us to maintain road signs, different accidents, events, which are short-term events, again connected to the transport network, to use it in transport forecasts and to change characteristics of network links, graph, and to use it in modeling. We also have monitoring of vehicles. It's a model for tracking of different goods, vehicles, their characteristics, tracks on the network, and to compare each other, to analyze geozones, which we pass through, and so on. So the standard way of analyzing fleet management. The model for forecasts, there are different situations where we use it. So the base one is for dynamic transport assignment and to real-time forecast in dynamic what will happen in a 1 hour. And also we use it to combine different sources of data and assess impact of different events, incidents, or changes in the city or agglomeration. So one of the last, I think, models is a traffic control center. It's a dashboard component where you can see data aggregated from different external systems, visualized on the map and also in widgets to understand the current status of all the systems, all the hardware, software, and what is happening on our transport network. So it is highly customizable and can be triggered for customers' needs in different situations.